guys, welcome to the channel. Let's learn mechanical engineering. In this channel, as we know, we discuss about mechanical engineering at large, and since we are discussing nowadays with governors, and after discussing Watt governor, Porter governor, and Proell governor, we are now come to the topic of comparing each other, the Watt, Porter, and Proell with each other, right? Where do we use this thing, Watt governor? Where do we use Porter governor, and where do we use Proell governor? As you can see, we have derived the formulae of first one is the Watt governor, h, Porter governor is the height, and the Proell governor height. Yeah, as you can see, there is just certain things changing in each of the formula. In the first case, h is equal to 895 by n squared, then h is equal to 895 by n squared plus 1 by 1 plus capital M by 2m, where m is the capital M is the mass of the sleeve, and small m is the mass of the fly balls, or the governor balls, and q is the ratio, as we know, q equal to 10 beta by 10 alpha. In the sideways, I have given the simple layout that we know, where which portion actually representing h, and what is beta and alpha, as you all have actually studied, right? Okay, so as you can see, the arrangement of fly balls are different, and the significance of sleeve in the last two, and the position of sleeve in the first two. As you can see in the Proell, the position of the fly ball is quite different. Means in diagrammatically, we can actually compare the governors, right? So if we take this h equal to 895 by n squared, okay, let me show you. H equal to 895 by n squared. Supposedly 895 is our constant value k, right? It's a constant. So if we differentiate in terms of n, it will be what? Minus 2k into n to the power minus 3. So it will look like this, isn't it? Okay, in terms of n, yeah, in terms of n. So dh will be what? Equal to minus 2k by n square. If we keep out another n here, it will be dn by n. So if we see your change in height, yeah, your change in height dh is inversely proportional to 1 by n square. Means if the speed is increasing, your del dh, the difference of the height of the governor, will decrease, and moreover it's in square. So you have to know that whenever there is this increase in actually speed, means there is a reduction of load in the engine, and there is a speed increase in the governor spindle axis and of the entire governor, what happens? There should be considerable amount of change in height of the governor. But even after increasing speed, your dh is not increasing. That means the change of height is not happening. Means it is not following the governor principle. So we can see one fact that this Watt governor, since we have taken this equation of Watt governor, this is nothing but of Watt governor, right? We are differentiating the equation of Watt, but nothing else, right? So after differentiating, we are seeing that whenever we are increasing the speed of the governor in square terms, even in square terms, means inversely proportional to the square. Means if it is change in height, and if it is certain, so it will be square times inversely proportional, isn't it? So what will happen? When there is a reduction of load and the speed of the governor is increasing, there should be considerable amount of dh. But as the speed increase, there is not considerable amount of dh, change in height. Instead, it is decreasing. So it is not following the governor principle. Hence, our Watt governor cannot be used for high speed. So it will be some useful for lower speed. Are you getting my point? So we have to develop some type of governors where we can actually deal with the high speed thing. So going back to our slide where we are actually comparing the three governor, that's why we have given that written what governor can be used for low speed engines. Okay, so in case of this thing, if we change the ratio of m by small m, we can actually control the speed, means by putting a weight on the sleeve. You can see this in the right hand side. See, I'm sharing in the right hand side in both the Proell and Porter. If we increase the m by changing this ratio capital M by small m, capital M by small m, we are actually can control, we can actually actually increase the speed. If we go back to the slide, this one, see, along with it, if there is a ratio, means let me add in this way, if 895 by n square into what was our thing, 1 plus capital M by 2m q plus 1, this thing is the extra portion for Porter, right? We have found that dh by dn is nothing but minus 2k n to the power minus 3. So by controlling this thing, suppose your q is equal to 1, so your ratio will become m by small m. So by controlling this ratio, small capital M by small m, we can actually, it means by adding weight on the governor sleeve, we can actually change this behavior of what governor into Porter governor. Means, as we are seeing, this dh was inversely proportional to 1 by n square, but along with it, what is that? Along with it multiplied, this is 1 plus capital M by small m. Means if there is a change, if there is an increase in height, and so we also need, if there is a change in height, means if your speed is increasing, your difference of dh should also happen. Means it should also happen, the change in height should also happen. So what we can do, we can put this, we can introduce this factor, this ratio, and we can actually make this happen, which in case of what governor was not like that, it was opposite, which was against the governor principle. But we need, when there is speed increasing the governor due to the reduction of the load, your dh should increase. So by introducing this term, we are actually making it happen, means decrease in load, increase in the speed of the governor, we are also getting a considerable amount of h. Because as we know, if the sleeve doesn't move, means there is no change, considerable change in height, it actually cannot control the fuel supply, because whenever there is a reduction of load or increment of load on the engine, the fuel supply has to be adjusted. This is the governor principle. So by introducing this capital M by small m, we can actually make it happen. So we can use Porter governor for high speed engines. So going back to our thing, our comparison chart. So next we came up with this Proell governor, where the ratio, this ratio is always less than 1. So what happens, we have sorted out for low speed engine and high speed engine. Since we have left only the medium speed engine, if we multiply this entire Porter value with a value less than 1, this entire value of h will come somewhat less than the high speed engine. So this can be actually applied for medium speed by giving this extension. As you can see, this extension, we are actually making it happen for the medium speed engines. So in short, it is just the development from the watt governor. All the three actually are pendulum type governors, but in watt governor there is no sleeve weight. In Porter there is sleeve weight capital mg by 2, in Proell so capital mg by 2. In the watt and the Porter governor, what happens, the balls are in the junctions, like as you can see, the balls are in the junctions. But in case of Proell governor, balls are in the extension of the arm. So this is what actually we are trying to say, we are trying to study, discuss on governors and comparing with each other. It is always the governor height with which the speed of the engine is related. So by putting a weight on the sleeve, we can actually uh, change the nature of the governor. So I hope I have cleared some conception regarding these governors, this pendulum type of governors. Next time we will be discussing this thing, this ratio, how it can be q equal to uh, q equal to 1, or it can be q not equal to 1. Thank you. We'll meet again. Please subscribe, please like, and please hit the bell button. It helps me in making more videos for you. Thank you so much.